Hi everyone. So today we are going to solve this question. The name of the question is minimum number of operation to make x and y equal. So this question was recently asked in a LeetCode contest. So what we have in the question, you are given two positive integer x and y, and in one operation you can perform any of the four following operation. Divide x by 11 if x is a multiple of the 11, divide x by 5 if x is a multiple of 5, decrement x by 1, increment x by 1, and we have to return the minimum number of the operation that are required to make x and y equal. Okay, so this was the question, and how I'm going to approach this question. So what we have two variable x and y. We have to make these two value equal, and we have four operation. One is the divide by 11, another is the divide by 5, other is the increment by 1, and last one is the decrement by 1. Okay, and we have to return the minimum number of the operation in order to make x equal to y. We can only perform operation in x, not in the y. Okay, so how we are going to solve this question? So basically this is a pretty much standard question from the BFS, where we are performing all this operation in a level wise. Suppose currently I have x. In one step I can divide it by 11. Other option that I have is divide x by 5. Other option I have is that increment x by 1, and last option decrement x by 1. So these are the four operations that I have if I perform one operation. Okay, and for this value again I have four possibility. Suppose this value is z, then again I can divide z by 11 if this is a multiple of 11, and again I can divide z by 5 if this is a multiple of 5. Again I can divide z by, sorry, not divide, increment z by 1 and decrement z by 1. And suppose this value is again z, or let me take any other variable name. Let this value be p. If p is multiple of 11, then p can be p divided by 11. If p is multiple of 5, then p can be divided by 5. If p is not any condition, if we can simply increment p by 1 and we can decrement p by 1. So at each level there will be these four steps possible. So we have to return the minimum level at which our value of this value will become to y. Okay, so yeah, this is the pretty much straight algorithm. You just have to use simple BFS logic in order to solve this question. Let me show you the code. Maybe it might be possible that you are not able to understand what I'm saying, but this is a very much pretty standard algorithm that are straightly used in BFS question. There are many BFS question like uh, rotten oranges or from uh, some kind of the question where we are given one position, starting position and ending position. We have to return the minimum number of this step in order to reach from the start to end, this kind of the question. So whenever we are given question in which we have to return the minimum level or the minimum number of the move, and we have more than uh, 2-3 possibilities in each step, then we use BFS. And why we are not using DFS, this can be a question. So we are not using DFS because how DFS work in a depth wise manner. So suppose my answer will lie somewhere here in the fourth position. To reach to this position, what my DFS will work, how my DFS will go to here. It will first check from here till here and go in the depth, again depth of this tree, depth of this tree, depth of this tree. It will check for each and every possibility, and at last it will reach here. So this much computation is wasting my resource of the CPU. So in order to avoid this much computation, we are using a simple BFS logic. So I hope you understand what I'm trying to say. So let me just show you the code. Before showing you the code, I will highly advise you to write the code on your own. So this is the code, like a normal BFS algorithm. I'm taking a queue data structure and a map int for making the uh, making the count of the visited array, visited element. Suppose this value, this x plus 1, this value and this value are equal, so we cannot recompute again and again them. So we are storing this value in a data structure. We can use any kind of the data structure, but for this problem I'm using a map to store this value and to avoid the recomputation of this value again and again. Okay, so I insert a value in the queue, then mark it as visited while queue is not empty, and checking for each level. If the current value is equal to y, then simply return the count is the number of the level till now. And then I'm computing the for value: is a equal to 10 by 11, b equal to 10 by 5, c equal to 10 plus 1, d equal to 10 minus 1, and checking if temp is multiple of 11 and it is not visited till now, then I am inserting that value in the queue and mark it as visited. Similarly, I am doing the same operation for the for a multiple of the 5. I'm checking if it is a multiple of 5 and it is not visited till now. I'm inserting that element in the queue and marking it as visited. Same for the third operation, that is the temp plus 1, and same for the fourth operation, that is the temp minus 1. And in between, if I'm getting a value that is equal to y, simply I'm returning count from here. So let me just try to run this code. Yeah, I'm getting the right answer. Let me try to submit this question. Yeah, it is getting accepted. So thank you everyone. Thank you.